What's happening there, YouTube? Genji here, and welcome back to StarRupture, where we're about to complete delivering 1.07 million data points worth of domes to Selenium Corporation, capping off level 15 and 2 of our 5 corporate ladders.
The cargo reached its destination.
And there we go.
Selenium thanks you for the order. Your work is restoring their faith in the prison system.
I bet it is. 6 hours of churning out domes over the past 2 or 3 days. I pop in every now and again to run this in the background while doing some other things. I just have to run around for a bit and shore up some deficiencies that we have, which I'll go over here in just a second once we claim our 100 quartz ore prize. Hardly worth the effort, but having that 100% bar completely filled is mighty satisfying. So let's go take a look at what I did in the meantime. Our existing assembly lines actually held up rather well. I only had to deal with 2 major deficiencies, the first being uberfilament here. We were majorly deficient in uberfilament production. We only had 2 of the required 5 going from our RTSC generator path to the dome path. And I think at the end of the last episode, I had created a 3rd that was kind of limping along on the excess of our receivers for the first 2. But I did end up having to create an additional 3. Let's see, we had... 1, 2, 3, so this was the 3rd, and then this is 1, 2, and 3. These are brand new, pulling down materials from 2 additional receivers. I set up a 3rd receiver here for calcium powder, but I wound up not needing it. The epoxy, we actually didn't have to manufacture anymore. Our epoxy storage is sitting mostly untouched since upgrading from compounder V1s to compounder V2s. So we're way overproducing epoxy, but we were way underproducing gothite lattice. I actually had to set up a completely new factory for gothite lattice that I'll show you right now. Just to the north of our west gothite base, which is off there in the distance, that's where we were pulling down individual gothite nodes, creating gothite ingots, and then dispatching them to supplement various assembly lines throughout the map. I set up a new base with 6 laser miners, or laser drills. These are feeding into 6 pyroforges, producing regular gothite ingots in the center, wolfram steel ingots on the left, and titanoferrite ingots on the right. These are then combining their outputs into V1 storage depots and then being distributed across 3 sets of rails to 6 mega presses, all manufacturing gothite lattice. So we were severely underproducing gothite lattice for the dome track. And several items, several paths in the dome track required gothite lattice. So we wound up overproducing those, distributing them into a V2 storage depot, then dispatching them back to our 3 assemblers making uberfilaments, as well as a dispatcher that sent the excess to our original gothite lattice manufacturing in our mega press base. So thank you to everybody who left a suggestion in the last video that I try using a V1 or just a slower rail to kind of moderate our output into a secondary line so that I can dedicate the bulk of our production into what we actually want to produce, which was uberfilament. So I wound up using this V1 rail to send just a few excess gothite lattice back to our original assembly line. So that's a good suggestion. And yeah, thank you to everybody who suggested it. So I think that pretty much covers all of our major supplementing that I did between episodes. We did end up running short on reinforced frames, but we had actually produced so many scaffolds before we got all of our other ingredients up to par that I didn't actually end up needing any additional reinforced frame, and I actually went up with a bunch of extra scaffolds that didn't get used. So I think the first thing that we're going to do is go and shut off all the manufacturing for our dome line so that the rest of our factories across the map can begin to back up and accumulate some buffers and some storage of some materials that we're going to be using going into our production of satellite bodies for Clever Robotics. So let's go do that. So I'm just going to comb through our Selenium factory and turn off any assembly lines that we're not going to need for our remaining 3 corporate tracks. I'm fairly certain we're going to need more nanofiber, so we'll leave that online, but I think everything else can be turned off. We're not going to need scaffolding for anything else, so we can turn off all of our constructorizers producing scaffolding. These are just using up resources for nothing at this point. Okay, those are offline. Up at the top, actually forget what we're making here. Is this condensers or this is airlocks? I don't think we're going to need airlocks either, so we'll turn off airlock manufacturing. We'll definitely turn off dome manufacturing. Don't need any of these. And down here, we have converters. I'm pretty sure converters are only used in domes. I think I checked that before we set up this rail because I was going to put them into a storage depot originally. So we'll shut this off for now as well, and I think that's everything else that we're making here. So this factory is going to be mostly dark except for nanofiber. But that means we can get started on our Clever Robotics track. So let's take a look at Rupture Planner and see what we're going to be making that's going to be new for Clever Robotics. So here's the production chart for satellite bodies in Rupture Planner. We're going to end up making 6 new materials and expanding one of our existing factories. So let's start at the very beginning with stabilizers. We're going to need a lot of stabilizers, 14 fabricators worth of stabilizers, which is significantly more than we're currently manufacturing. If we look at RTSC generators, we only needed 5 fabricators worth of stabilizers for RTSC generators, so we're going to have to more than double, nearly triple our number of fabricators that we're manufacturing. But luckily, these use titanium rods and rotors, and we produce so many extra titanium rods. We have dispatchers for all these things just laying around waiting to be used. So we're finally going to put those to use in these stabilizer factories. This is going to feed into Onboard Instruments, which is going to be a new item we're producing. We only need 1 assembler's worth of Onboard Instruments, which are going to combine stabilizers with reinforced housing and... what is this up here? Electronics, which we have plenty of. I believe we only need 4 furnaces worth of electronics. Yeah, 4 furnaces of electronics, and we need to double that, something like 8 furnaces for RTSC generators. So we're way overproducing electronics, so we're good there. Our next item we're going to be making is rocket fuel, 3 constructors worth, or constructorizers worth. We're going to be making 1 assembler's worth of scanners, which was the top-end item in the early access version. We're also going to need to manufacture rocket engines in a facturer. We're going to need to make ion thrusters in a constructorizer, and then finally, satellite bodies will be our final turn-in. So, not too bad for this one. 6 items and a little bit of reinforcement on one of our existing factories. So, let's hop to it. For our Clever Robotics factory, I'm going to use this open field here on the east side of the map, just to the northeast of our new Titania base. Right about there. I've already put down a base core and a teleporter, which we've called appropriately Robotics Factory, as well as a few base core amplifiers. And the first thing on the menu is going to be to get our stabilizer production online. So I think we're going to lay this out in this direction, with our factory line starting here and running to the right. Now let's take a look at our flowchart or our build planner for our 14 lines of stabilizers. This is pretty simple compared to what we've been building recently. We're going to need 1 receiver for wolfram bars to manufacture wolfram powder in a furnace, then into wolfram plates and wolfram wire in Fabricator V2s. We're going to combine that with 565 titanium rods per minute, which is going to be an additional 3 receivers. Those will then feed into 5 Fabricator V2s producing rotors, and finally 14 fabricators making stabilizers. So let's start with our receivers. We know we're going to need 1 for wolfram bars, which we should have 1 left over still. And what's going to be our baseline for our factory? I'm going to lock our Z, and we'll just drag this to the left until we can no longer drag it over. So right here. And then what's our depth going to look like? I just don't want this to impact our base core slash teleporter over there in the corner. So let's go right here, right? And then we'll run this line in this direction. So we're gonna have 1 for wolfram plate or wolfram bars. We'll grab our last available W bar from the very beginning of the game in our smelting basin. This will be W bar RX12. Oops. RX12, like so. That's going to feed into a furnace V2 first, so we'll set that up. We'll flip this around this way so that we're spinning out in the front to then feed into our additional fabricators. So this is going to be making wolfram powder out of wolfram bars. We should probably buffer this, because we are going to have to split this into a few different places. So let's put a storage depot V1. Rail it out. We're going to set a rail modulator here. And then I guess we can just come straight to the left like this. Split off into our furnace. This is making wolfram powder. Come back to the front. We'll send this along into a Fabricator V2, making Wolfram plates. We'll load this from the front, so we're going to have to bring our rail of Wolfram bars around. Let's grab a rail support. We'll do a rail connector right here so we can join in our bars from the back. So here, into our Fabricator, and then we need to bring this to the front. We need, let's say, a rail connector right here. Straight, then back. There we go. That should be our inputs for Wolfram plates, Wolfram bars, and Wolfram powder. Perfect. I wonder if we should have spun this around. Yeah, it'll be fine. We can bring it back to the front again. So, let's do that. We're going to need an additional Fabricator for Wolfram wire, which is also going to be fed from the back, so we'll do this way. We'll grab a rail support to take our output and then feed it back to the front with a rail connector here. And a matching connector there. So this to here. Send it forward. And from here we'll probably dip down, but we'll worry about that in just a moment. Let's get bars into this Fabricator V2 that's going to be making Wolfram wire. So we'll bring this forward again to here, should be fine. Straight in. So we should now have everything that we're going to need, at least made out of Wolfram for production of rotors. So let's grab the output of our Wolfram wire. We'll bring this down 1. Send this to the right. We now need to bring in 3 receivers worth of titanium rods, and we're gonna combine 2 of these into 480 and then have 1 independent receiver to fill in the additional 80 or so to bring us up to 565. So in this case, I think we'll buffer in the front. So let's go 1, 2 back. We'll put down Storage Depot V1. We're gonna need to bring up a second receiver to combine with the first. So we'll put supports in the back. Bring this up 1, 2. Supports. Here's receiver number 2. And we'll combine both of these outputs, 1 and 2. This will be 240 and 240, giving us an output of 480 from this receiver, which we'll set to titanium rods. And we'll bring down titanium rod TX10. This will be T-rod RX10. And then up top, we'll bring down titanium rod TX11, T-rod RX11. There we go. We're gonna need 1 more cargo receiver right here. And we might as well buffer this as well. Auto-saving. Alright, bring this to the front. This one will be T-rod TX12 to T-rod RX12. There we go. Titanium rods. So this should be all of our raw inputs. So let's put down our 5 Fabricator V2s. Spin this way. We're gonna have enough room for 5 in a row. Let's see, 1, 2, 3, 4, and 5. Just barely enough room. I may need to pull back one of these staircases, but that should be fine. So we'll set this up in a row. This is going to be consuming only 43 of our titanium rods, so technically, I guess we could, if we wanted to make this a little bit more space efficient, we could put this stack of receivers on our stabilizer row and just use a single output for our fabricators here. But I think it should be alright if we do our row of stabilizers facing in towards this row. That way we can just send this on a rail across and then directly into our row of fabricators here. So I don't think it'll be a big issue. Let's go forward with this layout. So let's set up our rails for the inputs into our fabricators. And I believe, let me double check. Let's check our ratios. I think we should be able to squeeze all this onto a single V3 rail. So we're going to be making rotors here. We have a 6-second manufacturing time, so that's times 10. And we have 1, 3, 4 input items, so 40 per machine. 5 machines total brings us to 200 total items per minute, so that's well enough to squeeze onto a single rail. So we'll do a single distribution rail. I just realized that I put these too far back, so let me scooch these forward. Just like that. So now we'll set up our rail distribution. We'll take a single line of rail modulators going to the right. Lock our Z. 1, 2, 3, 4, and 5. Luckily we come up over the top of that rock. And actually scooting these forward should give us a little bit more room to get a rail around the back, perhaps. Trying to decide, I think I might actually bring these back to the left, and then bring these through, and then our main distribution rail into our stabilizers can be right here, but we'll worry about that in just a second. Right now, we need to get all of these combined. We need a single leg of titanium rods, which I think we should be able to do at level. In fact, I think we could probably bring this up as well. We don't need to bring this down anymore. Actually, we will, because I think we're going to need to get this under this line over to here. So what we'll do is we'll just put a rail support right here to catch that from here to here, and then we can get this out of here without having to worry about getting around that. And what I think may work better is if I go over the top. This is getting a little bit picky, but I think it'll be all right. So we'll go up instead of down, go over the top of this, and then back down, just so that when we bring this rail out, I can just put a regular at height rail right here, not to worry about it. So we'll combine the output of these titanium rods together with the output of our rotor manufacture. And we're gonna need our wolfram plates, which is right here. So this into, this needs to be a rail modulator or a rail connector. Now we send this forward. That's wolfram plates, wolfram wire, titanium rods, all sent together to our fabricator V2s to manufacture rotors. Hook everything up in our distribution line. Oh. There we go. That's all of our inputs. So let's get this hooked up to some power, which is coming from our teleporter area. I have a chemical generator in the very back, right there. So we should have plenty of power for this factory. I'm actually kind of surprised the staircases aren't delivering power. I wonder if I can put a platform. How can I get this? Is there a staircase here? There's not a staircase there. If I do a half a shallow stair and then a platform, that'll do it. Perfect. Okay, let's just bring this down a little bit more. Stairs. Okay. Now we have power. All of our receivers are hooked up, so I should be able to just set our recipes for rotors on each of these fabricators. And 5. We wait for some materials to arrive. Right on cue. There's 3. Where's our wolfram bars? I thought I set that one first. Oh, they're already there. This needs to be set to wolfram bars. There we go. Now everything can flow. So, wolfram powder. Wolfram plates. Wolfram wire. Titanium rods. This is emptying out because it's going into the machines. Right. And then rotors. So now I need to bring this back. And before I decide where to bring our distribution line through, let's set up our fabricators. So we're going to need 14 of these. that are going to need to be split into 2 or 3 different rails because they're consuming 522 titanium rods per minute, which is going to exceed the size of a V3 rail. So at the very least, we'll need 2, if not 3. Let's place down or figure out how we want to organize this. If we're going to do 2 rows of 7 or 1 row of 14. Let's see. I kind of like the idea of 2 rows of 7. It's going to make our rail distribution a little more complex, but it's going to look a bit nicer. I like the look of a double stacked factory. So let's see if we can do it that way. We're going to need maybe starting here, right? Because if we're going to do 7, we don't need quite as much width. And our incoming materials are going to be right here. So here's our titanium rods, and then our rotors are going to be coming back around this way. So if we start, say, right about here, we'll lock our Y or lock our Z, and then from this row we'll go forward 1, 2. There's 1, 2, 3, 4, 5, 6, and 7. And what I'll probably do is let's say every 2 fabricators, let's put in some supported platforms just to bring these up. So we'll delete these. And that should fill in the gap to make this a little bit more level with the end and also make it so we don't have to put an additional row of supports in the back. So we'll copy this again. So there's 2, 3, 4. We'll leave a gap. 5, 6. We'll leave a gap. And then 7. Supported platform. Been a little overboard. Let's get rid of you. And then we'll bring each of these up. 2 is more than we're going to need. But this will get this level with our other platform that we have there, just so our decks...
activity detected.
Just so our decks are even throughout the factory. So we'll put pillars on these. Like so. Put some platforms on top. Platform and platform. And then we can put our second set of 7. We'll bring this up right here. Lock our Z. 1, these are spun the wrong way around. I hate that it doesn't copy the rotation when you copy a building. Try that again. There we go. 1, 2, 3, 4, 5, 6, and 7. There we go. We'll continue the rest after the rupture, so I'll see you in just a minute. Moving right along, let's take a look at our ratios for production of stabilizers so we know how we're going to balance our rails. So in a stabilizer, each one of these machines is going to be consuming 1 rotor and 2 titanium rods every 3 seconds. That's 20 cycles per minute. I'm primarily concerned about titanium rods, so I think I'll just do a single dedicated rail for rotors. I just need to know how many machines we can fit onto a single 480 rail titanium rod. So 2 times 20 is 40 per machine. 480 divided by 40 is 12. So we can put 12 of these on a single rail. But I'll probably do maybe 10 and 4, just so that we're not maxing out a single rail, because trying to put a full 480 on a single rail generally doesn't work out very well due to the rail inefficiency. So let's do 10 machines and 4 machines. We're going to need to put 2 separate rails, 1 for titanium rods and 1 for rotors. I guess we could do this. These are pretty close together, so we're probably going to need to use... Well, you know, we've got the rail modulator 5s now, so we should actually be able to do this in a straight row with rail modulators. So if we do 1 at height facing this way, we'll go back 1 and then down 1. Let's see if this works. I can put 1 in the front, 1 in the back, and then if I repeat this, full height, and then down 1. I should be able to wrap this around the first one, like that, and then do one in the back, one in the front, right? I think that'll work out just fine. So 10 of these, so we have 7 on the first row, and then I'll loop this up on the end and do 8, 9, and 10. That way, since our distribution is coming from right here, I can then do our additional 4 straight up, 1, 2, 3, 4. So let's do that. We'll bring our rails through. Wrapping around like that. And then our top row, I guess, can just go straight through the center, right? You can do it from the side for symmetry, or not symmetry, but consistency. I don't really see any reason not to bring these perfectly straight. And then we need to do a loop up, which we can do with... We'll have to do... We can't have both loops facing the same direction or they'll hit, or they'll impact, so I guess let's do rail connectors. 1 at height, 1 down 1. Actually, we'll have to go out a little bit further with this because I need these 2 specific locations for rail connectors on top, or for rail modulators on top. So we'll go down 1 and then up 1. Then we should be able to wrap this around to here. Send this straight through to here. Then we'll do rail modulators. How do we do this? The lower one is in the back, so we'll go down 1, up 1, lock our Z, like that. Then we need our matching rail connectors on top. Down 1, up 1, lock Z. And we can bring these up and up. Or, just so that, because these are pushed out, just so that we don't intrude on this center space here. Not that it's a huge deal, but we can tuck this in the back. Like this. Make this open in the front. And now we just send these straight through. 1, 2, and we can continue this for the next 3 machines. So we'll copy, there we go. We'll do at height first, I suppose. We'll put this 1 and 2, that'll be 3 machines. Bring this down 1, lock the Z, 1 and 2. Send our rail through. And the top, straight through. Connect up our machines. 1 and 2. 1 and 2. 1 and 2. Now, our rotor line will need to continue. So we'll make the top line the titanium rods. So titanium rods for these last 4 will come up on this side, but our rotors will need to continue through. Because we're only using 260-ish rotors per minute, which is going to fit on a single V3 rail. So we'll bring these, rotate this, bring it down 1, lock the Z. We'll put these, I guess they can move up now, because our other set of rails will be on this side. We'll have to see how that works out. We'll put this here, 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 and here. And we'll continue this through like so. See if this is going to work out. If I put another rail modulator 5 facing this way, right here, I think this might get in the way. It will. So we'll do rail connectors at height. Directly in front. 1, 2, 3, 4, like that. Now we should be able to do modulator on the left, connector on the right, and then pass this around the connector to the next modulator. Yeah, that'll work. Let's connect all of these up. Pass it through. That's the end of the line for rotors. We need to bring our second rail of titanium rods up on this side. 1, 2, 3, 4. There's that track. I need to hook up all of our machines downstairs. I got a little carried away. There we go. So, let's get our distribution hooked up. We're going to need our largest set of titanium rods right here. So we'll grab a rail connector. And then a rail connector. Now let's bring this down. No, actually this is lower we said was our rotors, right? So we don't need to bring that down at all. We just need to bring this out. And we just loop this from here to here, right? There we go. That's our largest set of titanium rods. We need our rotors to be brought back to here. So let's put a rail connector and a rail connector. That should be fine because we brought that whole line up. Perfect. So if we send this through and down to here, perfect. Now I just need to get the output of our rotors collected together and connected into that connector. So we'll do rail support. Made a bunch of modulators. Lock the Z. Bring them all together. Two. 3, that was weird. A little delayed. 4. And 5. Then a rail connector on this end. Loop it out. Send it across. And there they go. Okay, and then our final 4 machines on top. We need to get from this storage depot. It doesn't have to be from this connector, just this storage depot. They don't want these plates to also be taking up space on this line. Let's bring this... We're going up top here. If we do a rail connector, you can probably just come straight out and then go directly up to there. I think that should be fine. Now we just need to set all of our recipes to stabilizers, stabilizers, and stabilizers. There we go. Now we watch the magic happen. For output, we know we're making 261 per minute based on our planner, so we know we can fit all of these onto a single V3 rail. So I think let's just collect everything going to the left, and then we'll put a V3 or a V2 storage here at the end. Let's start on the bottom, we'll flip this around, lock our Z. 1, 2, 3, 4, 5, 6, and 7. Bring it up. Lock the Z. 1, 2, 3, 4, 5, 6, and 7. Bring them all together. And 14. There we go. Now we'll connect these together in another rail modulator. Can we go directly in front? We might have to space this out one more. Hello? Give me this. Oh. Space this out one. We'll bring this down. join it with this. And we'll bring all of it into a storage depot V2. Into the back, or the side. We'll set this to collect stabilizers. And there we go. This should be all the stabilizers that we're going to need, both for satellite body production and for ion bombs when we get to Griffith's Blue Corporation. That's also going to require quite a number of stabilizers. So there's the first thing off our list. Now we can move on to actually producing our new items, starting with onboard instruments. For satellite bodies, we only need one assembler making onboard instruments, but if we look forward a little bit to Griffith's Blue and ion bomb construction, we're going to need eventually 3 assemblers manufacturing onboard instruments, so let's plan ahead a bit and plan for 3 assemblers worth of onboard instruments. That way we don't have to refactorize again once we get to Griffith's Blue. So to manufacture 3 assemblers worth of onboard instruments, we're going to need 33 reinforced housings per minute, 66 stabilizers per minute, and 33 electronics per minute, which should all be fairly simple, so 3 receivers for 3 assemblers. So we'll start our next row just past our existing row. Let's rotate this. Lock our Z, and we'll bring this out 1, 2, and then bring this as far to the left as we can. Let's say right here. That should be fine, and that lines it up with one of our existing buildings. So we'll do 1, 2, 3 receivers, then a space, and then our 3 assemblers, starting, let's flip this, just aligned in the back. We need a space of 2 in the front, so it'll be like this. So we'll go out 1, and we'll leave a space, 2, and we'll leave a space, and 3. So that'll be our layout. Let's put our buffers in here, a storage depot for each of our receivers. That brings it up to the front edge of our assemblers. We'll put supported platforms in the front and back. We don't know what's going to be on top of this just yet, but this will allow the power to flow through as well. So that'll be our setup for this row. We'll connect power once we get everything wired up. That way everything can start working in a synchronized fashion. So let's do our rails. Rail V3. From each of our receivers to each of our depots. Let's look at the recipe. We do still need to unlock this recipe, but we can at least get an idea of what our ratios are going to look like. For onboard instruments, this is 5-second manufacture, so that's 12 cycles per minute. We have 1, 2, 3, 4 items times 12 is 48 items per machine per minute, times 3 is just 144, so we should be good to collect all this onto a single V3 rail. Let's do that. We'll take a rail support in the front, and on the last machine, everything else will be a rail modulator. Flip it, lock the Z, 1, 2, flip it again, 1, 2, and bring it all through. And then out, and right to the end, just like that. So let's set, well, I guess we can't set our receivers yet because we have to create the dispatchers for this. So we're going to borrow off of our existing manufacturing. So we need stabilizers, which we already have right here. So this can actually, one of these receivers, probably this last one, just to make this easy, we'll make it disappear. We'll grab, I might need to dispatch some of these somewhere at some point. Almost certainly, because we're going to need stabilizers for some other things, for some other corporations. So what I'll do is, we don't need a 5, we'll just do a 3. Rotate this. Bring this here. And then I'll need to break one of these off. Right here-ish. So we'll do 1, 2, and 3 outputs from our stabilizer depot, and we'll just grab the first output and we'll send this to the left Can that work? Oh, I don't like that. Being kind of free-flowing like that. We'll make this nice and straight. We'll send this forward to this depot, and we'll make this stabilizers. Stabilizers. There we go. That way we have some other rails to put dispatchers here for some other things. Right along this row here, so it'll be something like that. And then we take rail number, or the rightmost rail. As well, just bring this through. I don't know where this is going yet, but just as an example. There you go, and then we have space for one more one more dispatcher. So that'll work. So this will come forward, this will be our stabilizers. Then we're gonna need our reinforced housings and electronics. So I guess we can technically set... We can set these right now. Electronics. And somewhere in here should be reinforced housings. Reinforced housing, there we go. So we'll name these, we can set these from the far end. This will be our housing for, what are we making here? Instruments. Confirm. And then this one will be electronics for instruments. Electronics for instruments, or instrum. There we go. So this is all wired up now. We just need to go and create some dispatchers and then hook them up to those receivers. Over here in our electronics factory, you can see I've added a few extra storage depots for electronics just so we can be stockpiling these in the background. We are going to need one additional dispatcher for electronics. So far, we may need some additional in the future. Let's see, I have one more output available on our frontmost storage depot. We'll bring this forward all the way to the end. We'll copy this dispatcher. Add one more multi-rail 3. Oh, we've just exceeded our power limit. So let's toss in an extra wind turbine V1, just so we don't overflow our thermal capacity. Rail V3. We'll grab this last rail. Not what I wanted. Thanks for the effort, though. It will go there eventually, but has to go through here first. Getting ahead of yourself. Okay, so this guy will be electronics for instruments. Instrum. We'll bring in electronics. We'll connect this to... What are all these generic cargo receivers, I wonder? I know we had a few cargo receivers we didn't end up using in our last episode, so I know at least 3, maybe 4 of these are from that. I'm not sure what the other ones are. At any rate, can't be that important if they're not being used. So this can be electronics for instruments. There we go. Perfect. And for reinforced housings here at our Mega Press base, I've got 2 storage depots filling up with housings which are connected to a multi-rail 3, so we should... Well, this output's kind of in use at the moment, but I guess we can grab just one of these other outputs since we're clearly not overusing our production of reinforced housings. Where can I squeeze this in? I guess just right here. I do want to leave some room for maybe some more... the opportunity for more in the future. Although I can't really put this in line with our others, so let's just put this here. No need to overthink it, and we'll take one output from this depot into here. I do think... Didn't I just... I saw the bar go red. I think I went over our heat capacity somewhere. I'm not sure where. It was probably here. Let me just drop one of these up there, just to make sure we don't overheat this factory. And we'll set this to reinforced housings. This will be our housing for instruments. We'll connect this to our housing for instruments. And there we go. That should be everything that we're going to need for onboard instruments. So let's go get the recipe unlocked. To unlock onboard instruments, we're going to need 100, because we've already turned in 500 apparently, electronics, 800 stabilizers, and 1,000 reinforced housings, which should be easy enough. So let me go grab those. Okay, we're ready. Assembler. Onboard instruments. We have 100 of our 600 electronics, 800 stabilizers, 1,000 reinforced housings, and 1,000, not 800 reinforced housings. There we go. And 2,000 data points. And we're unlocked. Perfect. Let's get rid of this. Bye-bye. Set our recipes for onboard instruments times 3, 2, 3. Here we go. We're assembling onboard instruments. So let's collect these and send them to the right. Rail support. Times... that is a good question. I would like to collect these in the storage depot V2, but I don't want to put this too close because we're going to put a second deck on top of this, and I don't know how far the second deck is going to extend. So for now, lock RZ. We'll extend this to align with the end of our first row. We'll send this down to here. And then rail modulate to the left. Collect them all together. Nice and easy. Oh, just short. We'll collect onboard instruments. There we go. Ooh. They got little lights inside. Neat if we could have like a display case to show the items just so we can like visibly see the models statically so we're not trying to look at them while they're flying along our rails. Maybe for the future when we get some more like interior design stuff or some base accessories. Anyway, there's our second factory and our first new item. So let's take a look at what we're going to manufacture next. Next up, let's continue with the assemblers. We'll make our scanner factory next. We're going to need just a single assembler making 6 scanners per minute. And let's look forward to ion bombs, which are also using scanners, but we're only going to need 3 here. So either way, 1 assembler worth of scanners looks like it's going to be enough. So we're going to set up a single assembler for scanners, which is going to require 18 generators, 72 stabilizers, and what is this? Lenses, 18 lenses per minute. So again, one of these is going to be local. We have our stabilizers in this factory already, so we're going to set up 2 additional receivers. Same configuration as before, although I am going to need to delete some of these cosmetic platforms I threw down. We'll get rid of 1, 2, and 3 so we can put our supported platforms in the corner. 1, 2, 3. Like so. I mean, I guess we could go a little bit overboard and bring us some additional pillars, but at the very least, we're going to need 1 in the corner of each of these. 1, 2, and 3. That'll allow us to bring up our storage depots. Lock RZ. 1, 2, and then, do we want a second storage depot, or do we want to just pull off the first storage depot? I guess we can do an extra storage depot. Whoop, auto-saving. And then we can bring this line up the side, since we're clearly not using very much of this 480 rail. So we'll set that to stabilizers in just a bit. Let's bring up our receivers. The building is not stable, so we're going to need some additional support. We can go in the back, because we have this row right here, which is not being utilized. This is our output rail row. So we'll unlock our Z, do 1 and 2 in the back. And I think between those pillars and the pillars in the front, that should be enough stability to bring these up. 1 and 2. We can replace our extendable walkways. There we go. Keep things looking neat. So, rails out to our receivers. Then pillars. Let's just do all 4 corners. It's overkill for this assembler's footprint, but it looks a little bit nicer. 1, 2, 3, 4. Copy. Rotate. Rise. There's 1 assembler for scanners. Do a rail support. Lock the Z. 1 here. Obviously, this is all going to fit onto a single V3 rail. Modulators facing that way, and then bring it all together. Perfect. Okay, let's set this storage depot to stabilizers, so this can be filling up while we're off making our dispatchers. Stabilizers. We'll call this receiver generator for scanner. Forgot what we were making here for a second. We'll set this to generators. Generators. This will be lens for scanner. Lens for scanner. And then we'll set this to lenses. Lenses. Okay, let's go create our dispatchers. Alright, here's our generator factory in our assembler base. So we have 1 extra output from our storage depot V2 for generators, so let's see if we can just drop another dispatcher right here, and then worm a rail from here to there. Incredible. We'll have this pull in generators. We'll call this is generator for the scanners, and we'll connect this to generator for scanner. Off they go. Let's go do lenses. Lenses are here at the very back of our compounder bay, and it looks like we only have 1 dispatcher currently sending lenses. So we'll copy this, see if I can bring this up to here. I can. I will have to drop in some extra heat dissipation. We'll grab an extra discrete rail out of our lens depot. Let's get up here. Call this lens for scanners. Pull in lenses. Connect this to lens for scanner. And there they go. Let's take care of our heat while we're here. Base core amplifier V2. This needs to go in this space right here, I believe. Everybody happy? Everybody's happy? Okay, let's get back. Okay, looks like all of our buffers are filled up. We have lenses, we have generators, we have stabilizers. So let's unlock our recipe. We're going to need 400 lenses, 100 generators, and 400 stabilizers. Easy enough. Okay, here we go. Assembler, 400 lenses, 100 generators, 400 stabilizers, and 3,000 data points. Unlocked. Let's get rid of our hab. And let's set our recipe. Make me scanners. 1, 2, and 3. There we go. Manufacturing scanners. So we only have 1. So we just need to bring this into a storage depot. We can do... We'll do a V1. I don't know we'll need too many of these. Let's bring this up to here, lock our Z. That's not right. Get rid of it. Rail out. Rail in. Collect scanners. There's our first scanners. Now, scanners are used in two places. They're used in satellite bodies and in tracking devices. So we'll set up 2 dispatchers over the top of our first row of assemblers. So we're going to need a few more pillar supports. If we bring up... I don't know if we'll need this back one. We'll bring it up anyway. And then I'll create one more set of platforms here. We'll bring these pillars up. To there. Let's create 2 dispatchers. Rotate this around. Lock our Z. 1, 2. There we go. That actually worked out perfect. And they are not level, so I will actually bring these forward. So we'll need to bring these forward. Come on. Stop blocking. There we go. 1 each. And then we'll put our cargo dispatchers aligned to the front like so. And there we go. So we'll do a rail support on the end. And then I'm going to do a rail modulator. These will never be running at the same time because they're for different corporate tracks. So these will essentially be the same 480 item output. As long as we remember to turn off our facturers and we're done with them. Where are we? Right here. So scanners. Whoop, don't fall. This is going to be scanners for sat body. Pull in scanners. And then this one's going to be scanner for tracking device. But I'm not going to set this to pull any yet because the output of this is so low. I don't want them to be wasted filling up this buffer that's not going to be used for several more episodes. So we'll just let this fill up this dispatcher and this storage depot for now. So let's go look at our next item. That concludes the assembler portion of this build. So now we're going to move on to our constructorizers. So we have 2 items we're going to need to manufacture in constructorizers. One is rocket fuel, and the other is ion thrusters. So let's start with rocket fuel. We're going to need 3 constructorizers worth of rocket fuel, which is going to be pulling in sulfuric acid, refined oil, basic fuel, and what is this last one way up here? Liquid helium. So we should have all of this available. We're just going to need to set up dispatchers. The only one that might be interesting is liquid helium. I know we have excess liquid helium, but I know that we have a huge number of dispatchers already set up for liquid helium. So we'll have to see where we can squeeze in some extra throughput for liquid helium. But let's start with laying out our constructorizers. So 3 total with 4 receivers. So we're going to start a new row, starting with 4 cargo receivers. We are going to get pushed forward a bit due to this little rocky outcropping, although we might be able to come over the top of it. Let's take a look. We bring this up to level, lock our Z. We can just barely squeeze some material out of here. So we'll go forward 1, 2, and I want to bring these as far to the left as we can, so we do need to put 4 of these in here. So there's 1, 2, 3, and 4. Oh, and we're under attack. Just a moment. What are you doing over here? Okay, back to it. Let's put down our storage depots for buffering. We'll lock our Z here. 2, 3, and 4. And we'll put a space and lay down our constructorizers facing this way. 1, 2, and 3. We just crushed our heat capacity, but that's fine. We have plenty of space for base core amplifiers. Let's put down supported platforms in all 4 corners. As we know, we'll need to have at least one more constructorizer factory on top of this one. There we go. We'll bring through our rails to our buffers, our storage depots. 1, 2, 3, and 4. So let's take a look at our ratios in this recipe. We're going to be making rocket fuel. It's going to be 6 liquid helium, 2 basic fuel, 3 sulfuric acid, and 8 refined oil every 12 seconds. 12 seconds is 5 cycles per minute, so all of this is times 5. We have 6 and 2 is 8, 3 is 11, and 8 is 19 times 5. That's 95 items per machine, times 3 machines is 285. So despite the count, you will still be able to fit all of this onto a single V3 rail. So we'll bring all these together onto a single distribution rail, starting with a rail support somewhere on this side. Let's lock our Z right here, buried in the rock. And then right here on this side, rail modulator for everything else. Flip it. 1, 2, 3. Flip it. 1, 2. Bring it all together. Then output into our constructorizers. And there we go. So let's start on this end. We know we're going to need liquid HE3 for rocket fuel. We're going to need sulfuric acid for rocket fuel. Refined oil for rocket fuel. And what was our last one? I think it was basic fuel for rocket fuel. Good enough. And I think we already have 1 rocket fuel thing set up, don't we? I thought I saw it might have been a rocket body. That was rocket engine, condenser rocket engine. Okay, so we need to set up 4 dispatchers for each of those things, although we do have some sulfuric acid already on tap. So I guess we can pull that down. I don't even remember what that was from. We can do this. Where's sulfuric acid? Right here. Sulfuric acid for rocket fuel. Let's grab SACD TX8. I think these are the 2 extra once we went from pressurizers or refineries to compounder V2s. We got some extra dispatchers worth. So here, we'll put these to good use. We'll set this to sulfuric acid, and I think that's all we had available. Yeah, that's all we have. So we'll do liquid helium, refined oil, and basic fuel. For liquid fuel, in between episodes, I did go and move these dispatchers forward by 2 so that if we need in the future to create some additional liquid helium, we have these 2 additional spots underneath. So these are no longer impinging upon the space that these dispatchers used to sit in. But for now, I just need to find a place to stick 1 additional dispatcher in all of this mess. I don't want to overload. This one line already has 3 dispatchers on it. And everything else has kind of got its own dedicated line. I guess we can just grab... Nope, auto-saving. We can just grab an output from one of these back storage depots, just so that we have a full 480 dedicated line just for this. We'll put this right here and bring this up. We'll bring in liquid helium. We'll call this LHE3 for rocket fuel. And we'll connect this to LHE3 for rocket fuel. There's one. And again, here in our compounder bay, we have refined oil as well. Well, this one's going to be a little bit interesting because it's kind of buried in the middle of the compounder bay. We do have, I guess, some space. We could pull down these extendable walkways and get an additional rail out for dispatcher down here. So let's do that. Let's take down this. And we'll put a rail modulator 5 or a multi-rail 5, either way, to get this out of here and then around the outside of this rail. We'll grab this, we'll go to the outside, we'll bring this forward to rail modulator 5, or multi-rail 5, down 1, lock our Y, bring this to here to give us a straight shot. Right? Looks like it. Then we can put a dispatcher on the end. Oh, here's one of our unused receivers right here. Let's just double check this. We can get this off the list. There we go. I think this was originally for something that might have been refined oil that we had in the base, so we didn't need a receiver for it. I just kind of left this. There's one off of our list. And that gives us some extra room for our cargo dispatcher. Although we have to put this outside of this overhang, so what's the closest we can get right here? Yeah. Bring this down as much as we can. Rail V3. Into here. Now this is refined oil for rocket fuel. Refined oil. Connect to refined oil for rocket food. There we go. Now we just need basic fuel, which is tucked away here in the back of our Atlas Field base. Let's get a dispatcher. We'll set this right next to our existing row dispatchers, and we'll feed a rail straight from our extra V2 storage of basic fuel. Right? Basic fuel. This will be basic fuel for rocket fuel. Basic fuel. We'll connect this to basic fuel for rocket fuel. That should be everything that we're going to need. Although I have no idea what kind of rocket fuel uses these ingredients or uses helium at all. Most rocket fuel uses an oxidizer, LOX, and then either like liquid hydrogen, not helium, and or like RP1 is kerosene. So I'm not exactly sure how rocket fuel works in this universe, but it's a very interesting formula. At any rate, let's set up our storage depots to act as buffers. So this is basic fuel. We'll set this to basic fuel. This is refined oil. We'll set this to refined oil. We've already set up sulfuric acid, which makes this liquid helium. Now we just need to apply some power. Supported platforms, we'll bring this straight through, like so. And then while we're waiting for items, let me go set up some additional thermal capacity with some base core amplifiers. Okay. Items are coming in. We are not overheating anymore. So let's plop down a hab, and we can get our recipe unlocked. So for rocket fuel, we're going to need 600 liquid helium, 800 basic fuel, and 1,000 sulfuric acid. Let's gather that up. Okay, we should be good. Constructorizer, rocket fuel, 600 liquid helium, 800 basic fuel, 1,000 sulfuric acid, and 6,000 data points. Now we are starting to get critically low on data points, but I have been gathering up a bunch of items that we can turn in for additional data points, so when we get critically low or we run out, I'll turn those in. But for now, let's delete this hab. Let's set our recipes to rocket fuel, and rocket fuel. Here comes our ingredients. And there's our rocket fuel, 2 at a time, every 12 seconds. So that's what, 10, 12 is 5 cycles times 2, so 10 per minute. So we're making 30 per minute. We can gather all these together on a single V3 rail. rail support, rail modulator, and then finally a storage depot V2. Oh, auto-saving. I don't know. We're not going to have another factory that has more than 3 constructorizers, so I can probably put this right here without having to worry too much about it. Let's gather all these up. 1, 2, and 3. And then we'll funnel these into our storage depot. Set this to rocket fuel. And there we go. Here's another one down. So let's move right along to our next item. Next up is going to be just a single constructorizer making ion thrusters. This is pulling in 4 different ingredients. We've got rocket fuel, which we've just manufactured. We have pressure tanks. We have valves and heat shields, all of which we should have available. We just need to set up some additional dispatchers for. So let's get started. So we're going to use the exact same setup for this factory. We're going to put a supported platform in the corner of each one of our receivers. And then also, well, I don't need it here on the end because this will just embed straight into the ground. Heard bug noises. Bring these up by 2. 1, 2. Platforms on top. Let me just double check. I think this is exactly the right height for this. Yeah, okay, we're fine. Oh, too far. So, let's cap off with platforms each of these pillars. And then for the last one, we're going to need to put this at height, lock our Z, and then put this right here. Unlock the Z, and then bring up our receivers. 1. Well, we don't need... Oh, look at that one down in the end. Just going crazy. We don't need one of these receivers because one of them is rocket fuel, which we're already making right here underneath. So we could... We'll probably just run a rail backwards for that one. So let's get rid of this guy, and we'll just do these 3. So let's bring these up. Lock our Z. These will support part of our receivers. We know we're going to need some additional pillars in the back for these. 1 each. Lock the Z. 1, 2, 3. Pair of pillars on each. Platforms. And then receivers should squeeze right in the middle. 1, 2, 3. Perfect. Hook up our rails. Just like so. And then we know we're going to need just a single constructorizer for this. Spin this around facing this direction. Since we only have a single constructorizer, we know that we're only going to need 1 incoming rail from this side. Rail modulator. Spin it around. Lock our Z. 1 and 2. And then we'll do a rail support here. And then another rail support here for our rocket fuel, which we'll bring in from this side. So, bring a rail through for all of our incoming materials. One and 2. And let's get our rocket fuel up here as well. We'll put a supported platform. I guess we can just bring this one up. 1, 2, like so. And then we'll put a rail support. Rotate. Lock it. 1 here. Yeah, 1 here. This can be at height because these rails are never going to intersect. If we bring this straight through to here, and then that just goes directly into the machine, that's fine. Then we just need to get this rail up here. So we'll take one output. We'll go straight up. Keep that as neat as we can. Perfect. Okay. So let's set up our receivers. And for ion thrusters, we're going to need valves, heat shields, and pressure tanks. So we'll set this as valve for ion thruster, heat shield for ion thruster, and P-tank for ion thruster. There we go. We'll set the buffers when we get all the dispatchers hooked up, so let's go do that now. Starting at the top, here are our valves in our megapress facility. So we're using 2 of these outputs. If I re-rail this to use the 3rd output, we can make this work. So we'll put this front into the left-hand side, center into the center, and then we'll bring this through a rail support. Nope, I can't lock that. Let's just put our own rail support, which we can lock. Lock our Z. We'll put this right here. Oh, where'd it go? We'll do a rail connector, I suppose. We got the Z level locks. We'll put this here. Bring our rail out, and then go one of these outputs. That's fine. That could have been a rail support, but no big deal. Okay, so now we can bring this down, and we'll bring up one more set of supported platforms. And actually, if we do this like right in the center, we should be able to do 1, 2. Lock the Z. Put it there. We'll do a multi-rail 3 right here. Bring this through to the end. Perfect. Go set that up. Pull in valves. This will be valve for ion thruster. We'll connect this to valve for ion thruster. There's one. Next up, we have heat shields, which have been sitting idle for quite a while here at our Atlas field base. As for where we're going to put this, we're going to have to go on the other side of this storage heap, but maybe on top of these dispatchers. So if I bring this up by... What is the offset for these again? It's like 15, which is 12 and 3. So if we go by 1, 2, 3 times 2, because I can't get one in the other end. Hopefully this will be enough. We'll add 12 on top of that for a total of 15. Grab a dispatcher. Place that there. Is that directly? Let's see, lock our Z level and our location. If I can bring this over by 1, that'll work. So we'll unlock that, bring it over by 1. Now it's directly on top. Perfect. And then heat shields. Give me this side. I don't even know if this is being used anymore. I think this is going to production of some part of our RTSC generators. That's no longer in use. But just in case, we'll take this one. We'll go into here. We'll catwalk along our rail to the dispatcher. We'll pull in heat shields. This is heat shield for ion thruster. Connect this to heat shield for ion thruster. Now we just need pressure tanks. And pressure tanks will actually be pretty easy because we have a dispatcher here for airlocks, which will no longer need to be manufactured. So I can actually steal this output We'll send this to P-Tank for ion thrusters instead, reroute this, and we'll turn this back on and call this P-Tank for ion thruster. There we go. No new building required, just a little rerouting. So let's get back. Okay, it's buffer time. Let's see. P-Tanks, we'll set this to pressure tanks. This is heat shields. We'll set this to heat shields. This is valves. We'll set this to valves. There we go. And then rocket fuel's coming in from the other side. We have a huge buffer of that already. So let's get a new hab set up and we'll unlock our recipe. Which is going to require urban sonar, ion thrusters. Here we go. 600 rocket fuel, 400 valves, 600 heat shields, and 400 pressure tanks. So let's go gather it up. All right, so I noticed our heat shields were coming in rather slow. So checking the chart, we're actually going to need 2 mega presses manufacturing heat shields for satellite bodies instead of 1 that we currently have. I'm going to duplicate this, and we're going to spin this around and grab an output off of our existing rails for a mega press of heat shields. We're gonna make a second mega press of heat shields right across the way. Let's set this to heat shields. This should pull in all the requisite ingredients. So now let's take the output and then just loop this back in. Rail support. Output, and then I want this to go into this connector, which will give us a straight shot at our existing storage depot for heat shields. And there go a couple. Okay, perfect. So now we have 2 mega presses making heat shields. All right, now let's get back to our recipe. Okay, we should have everything in hand that we need to unlock. So let's go to Constructorizer. Ion thrusters. We have 600 rocket fuel, 400 valves, 400 pressure tanks. Whoa, what happened there? 400 pressure tanks and 600 heat shields, plus 6,000 data points. I think at this point we're under 10k data points. So let me put down an analyzing station, and I'll turn in all of these that I've been hoarding for a bit. Damaged floor sample set, 10,000. A bunch of flight control units, 24k. A couple damaged local scanners, 7k. Energy storage, yada yada yada. There we go, we're back up to 55. That should keep us afloat for a while, so let's delete this. Let's get up here. Let's set our recipe for ion thrusters. Here comes our ingredients. There's our rocket fuel with its own dedicated line. And all right, there's ion thrusters. So I don't think we need to put these into a storage depot because I think these are going to go directly into our final constructions. So let's take a look at Rupture Planner again and see what we're going to be making next. All right, we're in the final stretch now. We have just 2 factory recipes left to go, one for rocket engines and one for satellite bodies. So rocket engine, we're going to have 5 input ingredients: nozzles at 6 per minute, condensers at 3 per minute, which we should have already set up in our assembler factory. We've got rocket fuel at 15 per minute, which we already are producing locally. Turbines at 3 per minute, so we'll have to set up another dispatcher for turbines, and then pumps at 9 per minute. We'll have to set up a dispatcher for pumps, but all of those we should already have available, so let's get started. Before we get started, we're going to have to supplement this factory line with some additional pump production. We currently have 2 mega presses producing pumps, and we're going to need 5 total for this assembly line. So I'm going to copy one of these, hopefully, copy, there we go. And we'll spin this around. And because I can't build directly on the ground because of this hazardous area, I'm going to instead build at this level above the ground. So we'll put down 1, 2, 3 additional mega presses. And if we look at our ratios, we have a 10-second cycle, which is 6 per minute, and then 3, 4, 5, 6 total items, so 6 times 6 is 36, so we can definitely fit 3 more of these onto a 480 item rail. So I'm going to actually jump off of these existing. We have this line right here. Let's see, we have one. We can actually do all of these off our existing connections. So we'll do this one here. We'll do this one here. And then we'll do this one here, just like that. One for each. Let's set each of these to produce some additional pumps for us. Pump, pump, and pump. There we go. And then we'll gather the output and then funnel this into an open connector here on the end of our existing pump storage. So, rail modulator facing this way. 1, 2. Collect our outputs. Send them to the right. And then we might as well make this look decent, so we'll put this at a diagonal so it has a nice curve. And then straight in. And there we go. So now we have enough pumps to continue. So let's begin our final 2 factories, which are going to be stacked on top of each other. Each one is going to be a single factor fed by differing numbers of receivers. We're going to be using 4 on our first row because rocket fuel is already in this factory. We won't need to dispatch it, although... Now, it should be easy enough. We'll just wrap this rail around like we did with our last factory. So that should be easy enough. So we're going to need 4 of these, so we'll line this up. I guess we'll set our Y on this one. We'll go back 1, 2, and we'll bring this forward to there, right? Right in the middle. Yeah. We'll put 4 of these in. 1, 2, 3, 4. Everything should be lined up. We'll do buffers in the front. Oh no. We've got stuff in the way. We can go to the left though. That's not the end of the world. Rails out. 1, 2, 3. Whoa. Not there. 4. Like so. We'll put down a facturer facing this way. Lock the Z. Now we can't actually do it at this height. But this should be okay if we do it here just to keep it level. Because this is a relatively small machine width-wise, so we should have no problem supporting the one that's going to go above this. Like this. 1, 2, 1, 2. Platform. I just want to make sure that this is going to work. Yeah, no problem there. So just to keep things flat and level, we'll do it like that. And then next is going to be hooking up, or not hooking up, but setting up our receivers. So take a look at our recipe. For rocket engines, we need nozzles, turbines, pumps, rocket fuel, and condensers. So let's start with nozzle, turbine, pump. This will be nozzle for rocket engine. This will be turbine for rocket engine. This will be pump for rocket engine. Then rocket fuel we have locally, and the last one was condensers. Condenser for rocket engine. There we go. So we'll set up our buffers once we get these receivers connected to dispatchers, so let's go do that. Nozzles are here in our Mega Press base, so we'll simply copy, find a spot, an open spot. Might have to be just facing this way at the end of the track. Because we're definitely not going to be able to squeeze these under. So we'll take... Do we have one extra output? Kind of. And we route this here. We can do that. We'll take this to the end of the line and then up into this dispatcher. We'll set this to pull in nozzles, and we'll set this to nozzle for rocket engines. Connect this to nozzle for rocket engine. There's one. Next up is pumps. So let's find a spot here. It's getting a little bit crowded in our Mega Press base, but I think we have a little bit of space right here to grab. I guess we can interrupt this since we're not pulling down a huge number of pumps. We'll interrupt this line. We'll toss in a rail modulator. We'll take an output. We'll send one here and one here. We'll call this one pump. Pump for rocket engine. Connect this to pump for rocket engine. Next is turbines, and it looks like we already have an available output from our turbine storage, so we'll just continue this down the line of multi-rail supports. Plop down a new dispatcher and a new multi-rail 3 right here. We'll connect this line to our dispatcher. We'll pull down turbines. We'll call this turbine for rocket engine. We'll connect this to turbine for rocket engine. Oh, and our condenser for rocket engine we already set up when we made our condenser factory, so that one is taken care of. Okay, let's get back to our assembly line. So now we can set up our storage depots. It's going to be nozzles, turbines, pumps, and we need to connect this to condenser for rocket engine. And now we can set this to condensers. There's 4 of our 5 ingredients. We still need to bring our rocket fuel in from the right side, but for right now, let's get a line of rails through. Here, let's do rail modulator, and then we'll just go over the top of this. Like that. Rail modulator, 1, 2, then a rail support. 1 here. 1 here, because we'll need to bring some stuff in from the right as well. We'll send all this through. In, and then let's interrupt this here. We'll turn this into a rail connector instead. Reconnect this. Send this to the left. And we can send one more. We want to do it up here because we have to bring it back down again, so we're going to like up and then down again. I think it might be better to just send this from the ground level to begin with. So right here, let's do this. Let's take this feed, put this in the front for once, and we can take this output, send this up. We can take this output, send this forward. No, that's not going to look very good. Let's just bring this to here. Let's lock our Z. We'll bring this to this line. And we'll bring this... We need to put a space here for an OC... Well... Yeah, an OCLV2, because there'll be another factory stacked on top of this. So let's bring this back to, say, here. Then bring this as far down as we can. And that should line that up. So let's connect this path here. And that get misaligned. That should be there. Now connect it through. Oh. Well, how did that happen? There we go. Okay. Here's all of our inputs. So, we have power applied through this rail now. So all of our drone receivers should start pulling down materials. There we go. Okay, let's set up a hab to unlock our recipe. And we're gonna need, in Facturer, 600 rocket fuel, 100 condensers, 400 turbines, and 300 pumps. So let's gather that up. Okay, let's turn it in. Facturer, rocket engine. We have 600 rocket fuel, 100 condensers, 400 turbines, 300 pumps, and 8,000 data points. Unlocked. Let's get rid of this. Let's set our recipe on our Facturer to rocket engines, which is a 15-second recipe, so 4 cycles per minute. Everything's filtering in. And there's our rocket engine. Now, and again, I'm not going to create a storage depot for this because this is mostly going to be a 1-for-1 to our final factory, our final Facturer. There's no real need to store these, and they're also not going to be used anywhere else except for our final Facturer. So that should be everything that we're going to need to do for rocket engines. So let's hop back over to Rupture Planner and take a look at our final factory. And here we are at the very end of our production chain with a single Facturer for satellite bodies. This is pulling in rocket engines, scanners, onboard instruments, all of which we have available in this factory. We also have ion thrusters available, and heat shields will be the only thing that we need to pull in from off-site. So a single receiver, I think, for this factory. Should be simple enough. Let's get started. So let's start by putting down our single cargo receiver and our Facturer. We'll bring both of these up by 2 pillars, slap a platform on top, bring up our buffer and our receiver for heat shields. There we go. Then our Facturer. We'll put a rail between our receiver and our depot. And then everything else is going to need to come from local. So we've got one of these. This is rocket engines in the back. We've got... this is rocket fuel. I think this is ion thrusters. Let's go take a look. I've already forgot where everything is. This is ion thrusters, indeed. And in the back here, we've got scanners. These will also need to go in. And down on the bottom is onboard instruments. So scanners and onboard instruments will be coming from the very back end of the factory. So let's set up... do I have this? Scanner for sat body. Yes, this already has a dispatcher. So this... I guess... if we wanted to, we could do dispatchers. Might be a little bit easier than running rails all over the place. If we're dispatching these, we might as well dispatch these as well. So we can actually bring these in. If we do a dispatcher right down here, put this next to our storage depot, and then I guess we want to run this... no, we'll put a rail right here. Down one. Connect this to this. Put our extendable walkway back in. This will be onboard instruments for sat body. Pull in onboard instruments. So we'll put in an additional receiver for this factory. Pillars. Platforms. Storage depot. And lock our Z receiver. just like that. We're over our thermal budget. We'll make this OB Inst for Sat Body. This will be Onboard Instruments. This one will be Scanners for Sat Body, right? Scanners. Next, we're gonna need ion thrusters and rocket engines. So we will need at least a third now for heat shields. So let's put another supported platform, or pair of supported platforms here and here. Pillar, pillar. Platform, platform. Buffer. And lock our Z receiver. Like so. Did we set up heat shield for this? I don't think I did. No, it'll be right in here. So we'll still need to set up a separate dispatcher for heat shields. So that'll be 3 ingredients. We also need rocket engines and ion thrusters. So rocket engines are down below. And then ion engines should be right here. So let's just bring a single rail for both of those. We'll lock our Z, and we'll go from here to, that's unfortunate, there to there, and then to there. Loop this around. It's gonna have a weird bend to it, unless I go like this. Just so many rail supports. To the ends, I'm gonna need to go below this, so let's bring this down. Rail support, bring it down 1, lock our Z. We'll bring this down 1 level. Copy, 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 no copy. We're gonna need to connect this together with the output of our facturer. So we'll bring this together here, and then unlock our Z. This is gonna go down below. Bring our ion thrusters up, and then we'll bring these to the front. We can do this diagonally like this. I believe since these are at a diagonal, they should give us a nice smooth curve, and then directly in. And then from this side, we'll do rail support here, then modulator, modulator, rail support. Yeah, that should work. We'll bring all these together. Oh. Like so. Bring this in. Okay, all that's left is to set up a dispatcher for our heat shields, so let's go do that. Heat shields is going to be another easy situation because our current dispatcher is sending to a receiver that's never going to function again. This was for the production of RTSCs, which we no longer need. I'm actually just going to redirect this connection to heat shields for sat bodies. Okay, and there we go. Easy enough. Okay, looks like all of our buffers are filling up. We've got scanners, we've got onboard instruments. Let's set our buffer for heat shields. There's that. And all that's left to do at this point is to unlock the recipes. So let's plop down another hab with an airlock and a recipe station. And as soon as auto-saving is done, we're going to look in Facturer and unlock satellite body. So we're going to need 600 rocket engines, 800 onboard instruments, 100 scanners, and 400 ion thrusters. So let's go gather that up. Alright, I think it's time we had a conversation about something, because I'm starting to get a little frustrated with the end game, or the late game in StarRupture. So let's do some math here. So this is 15 seconds per cycle. That's 4 cycles per minute. So this one machine, which is all that we're going to need to run our final facture at full efficiency, is producing 4 rocket engines per minute. Let's go back and look at the recipe station again. In order to even unlock the final recipe, this isn't even manufacturing anything. This is just unlocking a recipe in the recipe station. We need 600 rocket engines. At 4 rocket engines per minute, let's do a little math here. 600 divided by 4 is 150. That's 150 minutes. Divided by 60, that's 2.5 hours of running just this one machine non-stop, making rocket engines just to unlock the recipe that allows us to wait an additional 6 hours to turn in for our final level of Clever Robotics. The amount of artificial time bloat at the end of StarRupture is getting a little bit difficult to overlook. But luckily for us, we actually have another issue that we have to deal with while this runs, so we may actually fill up that 2.5 hours with some other nonsense, and that is our pumps. We made an additional 4 mega presses churning out pumps, but our 4 mega presses churning out pumps do not have enough turbines to run them at full efficiency, so we're going to go set up an additional turbine factory. And I think for this, just so we can do something new for a change, let's grab 100 quartz and 35 ignitium. We're going to go to the development station, and we're going to unlock the Ore Excavator V2, because we have just so much quartz now. We've got an additional 313 left over from turning in all of these levels of the top levels of corporate ladders, as well as doing some additional cave diving. But we have to hit the research, and we're auto-saving, of course. We have to hit the research button to complete this. Here we go. So we now have access to the Ore Excavator V2, and I don't know if I'll do it in this episode, but in one of the next 2 episodes, I am also going to unlock the Constructorizer V2, just so we can see the upgraded versions of everything. So let's go plop one of these minor V2s down. And we're going to use them on the far south side of the map, just past the White Lake Dome. There's a number of pure titanium nodes and an assortment of other titanium nodes, but primarily I'm interested in the medium and perfect titanium nodes. But with our extractor V2s, we should be able to extract even more than usual out of these. So let's plop down 1 on each type of node. So we'll take a perfect, we'll take an impure, and I believe this is a normal node here. Let's take a look. So starting with impure, the Ore Excavator V2 is able to pull 6 out of this. Does this say impure? This is impure, so the lowest we can get is 6, which is insane. Let's take a look at this. It's got 2 separate grinders and 2 different heat stacks, but otherwise very similar looking to a V1 Ore Excavator. So we get 6 out of an impure. We get 10 out of a normal node. And for pure titanium, we get 16. So that's a full 480, which we're going to split into 2 separate 240 dispatchers once we get this into a storage depot. We'll bring this down. I don't even know where we're going to build this. There's not a lot of room here. Let's bring this over to here. Bring this to level. We need some kind of power, so let's drop a... I don't know if we need a full 8200 just for some miners, but we'll drop a V2 wind turbine. We'll bring a rail down from our pure miner into here. That should be a full 480. We'll set this to titanium. Connect this to power. There we go. Our grinders are spinning. Alright, there's our recipes, and we'll set our storage depot to collect titanium bars. And there is a full 8 smelters running off of a single ore excavator V2. Wild. Alright, so now we can set up our twin dispatchers. One here-ish, or wherever we can squeeze this in that's valid. And then one here. Out. And out. This is going to be, I'm not even sure what we're up to at this point. Titanium bars in use. We have up to T-bar TX11, it looks like. So this will be T-bar TX12 and 13. T-bar TX12 and T-bar TX13. Pulling in titanium. Perfect. All right, let's move on. So let's plan this out. I want to replace those 4 extra mega presses of pumps that I created with 4 new ones that are fully fed by an independent system. Now we don't have to make all of this because a lot of this is stuff that we already have available, but let's take a look. Let's work our way backwards from pumps. Now from pumps, I know we're going to need more turbines because that's our main issue right now is that we're not producing enough turbines. So we're going to need 3 additional mega presses worth of turbines. Sulfuric acid, no problem. We already have an entire dispatcher, 240 exactly, available for dispatch to produce turbines and for pumps. Impellers we're going to need to create. But we're going a little bit too far back. Let's stick with turbines. So from turbines, we're going to need stators. Stators we're going to have to make. And valves we're going to have to make. All of this, I guess if we kind of zoom out and drag this to the right, this is all stuff that we're going to have to make. Going even further back, we have stabilizers. And I think we might be able to steal 72 per minute off of our existing stabilizer line, because a lot of the fabricators of stabilizers that we created at the beginning of the episode are not currently being used. So we'll take a look at that in just a second. So this is a maybe, but basically everything from this bottom line, all this calcium, gothite ingots, we don't need any of that. Stabilizer is a maybe. Helium-3 I have on tap. If we're not going to need to make stabilizers, we're not going to need rotors. Let's go up from here. We need nozzles, more than likely 2 mega presses full of nozzles. Helium-3 is going to be a part of that. That's already covered. And then titanium housings and heat-resistant sheets, I think, are the only 2 things that we're going to need to make. So this is actually not too bad. Basically, what is this? 1, 2, 3, 4, 5, 6, 7, 8 items total with maybe a 9th. But let's go check the stabilizers first. So right now, it looks like we're using only 2 of our 14 stabilizer fabricators. So I'm going to go ahead and say that we have some extra that we can pull off of for this particular manufacturing line. So right now, we have 1 cargo dispatcher that we hooked up and is not even being used, so that saves us the trouble. We're going to, for now, send this stabilizers. We're going to say stabilizers 4 extra pump. Confirm. All right, let's go set that up. And I'm actually going to use this flat location just to the side of the White Lake base to set up this factory. There's tons of space here, and this is kind of reflects my feelings on having to set this factory up right now. But let's start at the very beginning with cargo receivers. We're going to need to bring in... Let's see, how far to the left can we get this? Starting here, I suppose. We're going to need Wolfram bars. We're going to need titanium bars. We're going to need helium. We're going to need titanoferrite ingots. We're going to need wolfram steel ingots. And I think that's it. So let's get all these level. And just to save space, I think we can do them like this. Copy this, spin them this way. Let's do 1, 2, 3, 4. We have 5 total. We have titanium, wolfram, helium, titanoferrite, and wolfram steel. So we're going to put a multi-rail 5 in front of each one of these. Lock our Z. Each one of these is going to come out into a new rung of this multi-rail 5, and then we're just going to turn this and create a main bus system going this way, because a lot of this factory is interconnected, and I don't want a whole bunch of spaghetti going back and forth. So we need to do this from the outside in. So we'll bring this forward. Nope. What the hell happened there? It made a rail through the existing rail support. Great job. There's 2. There's 3. There's 4. And there's 5. So there's all of our raw ingredients. So let's bring in Wizingates for pumps. Let's bring in titanoferrite for pumps. Actually, well, I guess it doesn't really matter as long as we know what's on what rail. Because as this turns, this is going to be number 1. So if we make this actually titanium, D-bar, let's do 15 and 16. Were the ones we just created.
Let's see.
Drop those. This is going to be wolfram bars. Okay. Let's drop this. Drop. Then we'll do helium 3. 25. Then we'll do wolfram steel. Then we'll do titanium ferrite. There we go. There's all of our raw ingredients. So now we'll turn this way. We'll do inside out. And there's the first support, the first pole of our new main bus line. So I don't know how many we're going to need exactly, but we'll add another one on when we need it. So the first thing we're going to have to produce is wolfram wire and wolfram powder. So let's start there. Well, I guess we did titanium first, so let's do titanium sheets and titanium beams. Sheets are going to be a fabricator V2. So we'll put this way. Do we buffer this? I don't know if we need to buffer this. We will send this back 1. We need 1 for titanium sheets, and we need 2 fabricator V1s for titanium beams. So we'll space this out by 1. This is not going to be two-story, so we just need 1 adjacent tile to bring. Now this needs to be separated. Well, actually, we need 2 spaces, right? Because we're going to have 1 rail coming in. Although I guess our input rail can be to the left. So if we move all these over by 1, we can do input on the left, output on the right. Like this. And like this. And we'll grab our rail connector. We'll go down by 1. We're gonna grab rail connector for titanium titanium bars, right? And then titanium bars should be our only input into this machine for titanium sheets, titanium bars, perfect. Then we'll do another multi-rail to bring this forward. Lock our Z to here is how this works. So then this would come back up to rail 1. Everything else... Oh, interesting. These are actually so close together that it doesn't really work like that, huh? What if we go down more than 1? Copy. Copy, copy, copy. Of course not. 1, 2. We go down 2. Can we then send this forward? Yes, we can. Okay, noted. So this needs to connect back up to here. They're beeping so fast. Alright, send everything forward. Including you. Then... this actually needs to go forward 1. Like so. I guess we need a larger gap between these two. Fabricator V1. Lock the Z. We're gonna need 1, 2 of these. So if we do this here, and this here, I'm pretty sure we can pass this to the left. Yeah, okay, so that's fine. So we'll then do titanium beams here, times 2, which is more bars. Titanium beams. Rail V3. Bring down rail connector 1, 2. We'll do another output for titanium bars. 1, 2. We need to grab our output from here and send this back forward again. Rail support. Bring this down 1, 2. And this is going to go into another rail support next to this. This will be pull 2. Rail connector 1, 2. It's been a while since I've done one of these factories. It's coming back to me now. It's going to go down. It's going to go under. It's going to go up. There's rail 1 of pull 2. We're going to do the same thing here. We're going to collect these rail connector here. Down 1, 2. Feed these back into our bus. Send this forward. This is going to become rail 2. 1, 2. Lock the Z. Bring this forward 1. This is going to come to here. And here. At full height. So all of these are going to go forward. This is going to go underneath. Should technically be a rail support, but I don't care. We just want to get this through this quickly. Send this forward. There's 2. Next up, we have 2 furnaces making titanium housings. Furnaces. V1. Oops. V1. We need a gap of, I guess, technically 1. I think I went a little bit too far on this one. So let's, rather than going back, we'll just correct it going forward. So 1 and 2. And then we'll go rail connector. We're going to bring down the beams and the sheets that we just made. So 1, 2. 2. We want beams and sheets, or sheets and beams, whatever order they were in. So these are going to connect together, going to the left. We'll go into a rail connector here and here. Rail V3, send these on. 1 for this furnace. 1 for this furnace. These are making housings and housings. That should be it, right? Just beams and sheets? Yeah. All right, get out of the way. Collect these together. Down 1, 2. 2. Send them all forward. Rail support here, down 1, 2. Set up our supports for the next leg of our bus. 1, 2. We send all of these forward. This needs to come back up. Send all these forward. 1, 2, 3, 4, 5. Send both of these back forward again. 1, 2. We're gonna have a new connector. Down 1, 2. It's gonna be for titanium housings that we just made. Send this up to position 3. There we go. Next. Next, we have a Fabricator V2 for Wolfram plates. We'll put this back 1 at this level. Rail connector down 1, 2. This is going to need Wolfram bars, so this will go here. Wolfram bars are on 2. We'll send these back. Get this manufacturing Wolfram plate. Actually, let's do Wolfram wire here, because I do need actually Wolfram powder for this. So we'll do Wolfram wire first. Set up the next leg of our bus. Right here. Yeah, because we'll connect them. We'll collect these right here. 1, 2. Output forward. This is going to be number 4. 1, 2. Number 4. Send this back up to 2. Send it forward. I did it again somehow. There we go. Everything's brought back forward. Now we're going to need a furnace V2 for Wolfram powder. Down 1. All right. Let's grab rail connector. Down 1, 2. We're going to need Wolfram bars again, which is output 2. Up here, rail connector, well, I guess rail support. Down 1, 2. Rail connector. Down 1, 2. Send it for... Oh. Excuse me. It's too fat. What if we go from this side? That'll do. Okay. Send our bus forward again. 1, 2. This is going to be position 5. So we filled up 2 rails now. 2 multi-rail 5s. So we'll bring all this forward. And then we'll bring this under our bus to here. And then, oop, this needed to be rail 5. Rail 5. There we go. Moving along. Now we can make our Wolfram plates. Let's make sure we're not past the line. Fabricator V2, we're right up on the line, so this will be our last until we U-turn and go back. Let's bring this down. Lock our Y. Bring this forward 1. We're gonna need 2 materials here. Rail connector. We're gonna need Wolfram bars. And we're gonna need Wolfram powder. Bars are on 2. Powder is on 10. Send these to the left. Into here. Rail connector in the back to bring them back forward. 1, 2. Rail support. 1, 2. Set this... What? Set this manufacture Wolfram plates. Here's Wolfram bars. Isn't this Wolfram powder? Oh, this is nothing. Wolfram powder. Now it's Wolfram powder. Let's bring the bus forward again. To here. 1, 2, 3. We're gonna have a rail connector down 2 to bring this onto rail 11. These are much easier to count as well. Much easier to go by multiples of 5 than multiples of 3. Let's send these forward to 3 and 10. Send everything else through. There we go. Now I'm going to need to pull down one more material from a cargo receiver, not connected with the ground. Huh? Is our elevation going up? Yeah, I guess we can go up one. Just have to bring our poles down a bit more now. So next, actually this is nothing's getting pulled off here. We're just going to put something directly onto the line. So let's bring this down, guess all the way down now to a height of 1 in order to get this to the right height. 1, unless we bring the whole bus up a level. We'll bring the bus up a level when we do a U-turn. I want this to be nice and straight. So we'll go down to this level, right? Lock our Z. 1, 2, 3. Can this be? Can this go down? It can. So in this case, we only need to bring this down 2 as usual. So this will go into here. We'll bring this to the end. 1, 2. This is going to be position 12. And this is going to be somehow, I guess we need to bring power forward like so. This is going to be titanium rods. T-Rod TX6. T-Rod RX6. We'll bring everything forward. There we go. Next up, we're going to build 2 Fabricator V2's worth of rotors. Rotate this. Lock our Z. We'll go to here. Forward 1. We're going to need 3 ingredients here. We're going to need plates. Plates, wire, and rods, I believe. Rotors. Yeah, rods, wire, and plates. Okay. So, we know where most of this is. Wolfram wire, Wolfram titanium rods we just did, so we'll bring this down 1, 2. We know that's on 12. Our plates are on 11. Down 1, 2. And then Wolfram wire, I want to say, is this guy. Wolfram wire is on 5, 6, 7, 8, 9. Let's see, can we squeeze that? Down 1, 2. Can we squeeze 9 all the way over here? I think that's going to be in the way of some other stuff, so let's push all these out 1. Or here, we'll get rid of this. We'll put it here. And then we'll do these 2. To the right. And then we can do 9 straight down. Perfect. Send all this to the left. Rail connector 1, 2. Which is actually going to be 3 because the buildings for some reason can't go down as far. 1, 2, 3. And this should be straight now. Send it up. There's our rotors. Rotors and rotors. Collect these forward. This will be a rail support. 1, 2, 3. Send it up. There we go. Now we can send our bus forward again. Make sure we're locking our Y, and locking our Z for our bus, just so it's as straight as possible. 1, 2, 3. Let's get rid of this. Bring everything forward. Okay, and then we'll grab a rail connector. Bring this down. 1, 2. Send this through and up onto rail 13. Okay, I think we're just about out of room, so it's probably time to rotate our bus. So let's take 3 multi-rail supports. 1, 2, 3. And then 1, 2, 3. Auto-saving. There we go. And, yes, but let's give ourselves at least one more. Because if we do it like this, we can send all of our materials to the left, but our expansion will still need to be to the right. So if we put this right up against our existing line, we won't be able to expand our rail any. So let's delete this. Send this through like this, and then rotate. It's going to be a little bit of extra work to connect all these rails up, but it's going to look nicer and work better in the ends. If we do it like this, then we can send our bus this way, and then we'll still have one additional space right here in the middle to add another rail for the rest of our materials. So let me connect all these up. Alright, next we're going to need to make some heat-resistant sheets. So we're going to plop down 2 furnace V2s. Is this the right level? It's the right level. So we'll push this back 1. We're going to need 2 of these, spaced by 1. We'll get a rail connector down 1, 2. Right, these are fat boys. Just need to wave this around, which is fine because we don't have any pillars to worry about in this particular layout. And we're gonna need, going in reverse now, this is now 1, which I guess actually kind of makes sense if we're looking at it from the right direction, because if we're coming from this way, this is 1, and our machines are on our left, and then when we loop around, this is still 1, and machines are on our left, so that works out quite well. We'll grab a rail connector. We're going to need titanoferrite, wolfram steel, and helium. So 1, 2. These are all going to be on rail 1, so this is going to be a little bit interesting. I don't know if we can go that far without causing problems for these rails. Let's see. This is titanium. This is wolfram. This is helium. The first one that we need is right here. And then we need titanoferrite. Yeah, I don't want to bring both of these onto the same... Actually, we have created that problem for ourselves, haven't we? Because now these can share. We'll fix that in a minute. If I send this, I can't even send this to there. These rails are too dense. Rail connectors. 1, 2, 3. Let's see if this is going to be feasible. We need helium 3, titanoferrite, wolfram steel, or vice versa. I forget exactly. We can do a rail connector. 1, 2, 3. Grab 1, 2, 3. We'll loop this around. There. That way we're gated. I need to actually fix that on these. So let's delete these. One, two. Lock the Z. We need to bring this forward. Like that. Then bring these down. 1, 2, and 3. Then bring these backwards. 1, 2, 3. Like this. Then send them to the left. That way these are gated so that they can't rail hop. So if you have we have supplies coming down here. If these were connected, this would be able to come down here, jump onto this connector, and then continue forward again. So we send them backwards and to the left as a gating mechanism so that they cannot rail hop. We'll bring these back forward. And I just need to do that anywhere that we have 2 or more materials being brought together, which is only a few places here, so this isn't going to be too bad to fix. This needs to be gated. This is 2 and 10. There we go. Bring that backwards. Send it to the left. Now they're gated, and then these need to be sent back forward to 2 and 10. What else we have? This is a single, this is a single, this one has 2. This is 6 and 7. 6 and 7. Bring these back. Send them to the left. This is 1, and this is 1. Okay, not too bad. So, moving along. Did I send those forward again? I'm so sick of the auto-saving, but I know the second I turn it off, I'm going to need it. I'm going to crash, and I'm going to lose progress. I did not send these forward again. This is, of course, now in the way. But this needs to come down. Why is it coming to the side? That needs to go down. Forward. Now we can do 6. And 7. There we go. All right. Now we can move forward. So I said these were producing heat-resistant sheets. Heat-resistant sheets.
Rupture status stable.
Here it comes. Winding around. We've got titanium ferrite ingots. We've got wolfram steel ingots. We've got helium-3. There. Okay, we'll let those fill up while we work on our next bit. Let's bring our rails forward again. 1, 2, and 3, right? No. To there. And we left off on 13, so this is going to go to 14. We'll just bring this all the way down. This to here, and then up to 14. Hopefully we can bring everything forward without issue. Of course not. Well, I don't think anything else is going to need titanium bars or wolfram bars. So does it help us if we get rid of those? It does. I don't think we're ever going to need the bars again. Let's bring these up. There we go. And then everything else can come forward. And then we need to collect our heat-resistant sheets and bring them forward. Bring these all the way down. Need to not get too close to that. Oh, interesting. We don't have to do the wave if we bring this down all the way. It just skirts underneath its wide love handles. Okay, so that's going to be on 14. After this, we need to bring in another receiver, cargo receiver. Send this forward. Rail support. All the way down. Multi-rail. We'll bring these rails forward, or bus forward again. 1, 2, 3. I guess we'll connect these back up, even though we don't technically need these anymore, but I just like having all the rails there. Makes it look a little bit cooler. 4 and 5. So these are going to go all the way to 15. These are going to be stabilizers. Here we go. That just did that to get some power in here. So we're going to set this to stabilizers. I know we have a dispatcher. There we go. Stabilizers for extra pumps. And now our next step is going to be mega presses of nozzles. Bring this to here, flip it around. And we're going to need 2 of these. Bring our rails forward. $14 and $15. There we go. Rail connector. Let's bring this down. Yeah, we need to gate this. So this will be all the way down. So we're gonna need, let's take a look at the recipe. 4 nozzles. We need heat-resistant sheets, helium-3, and stabilizers. So helium-3, let's bring this down. 1, 2. Lock our Z. Bring this forward. Helium-3 is on rail 3. And then stabilizers we know is on 15 because we just put that here. And then heat-resistant sheets are on 14. This is going to be 3 for helium-3. And then 14 and 15 for heat-resistant sheets. Well, heat-resistant sheets and stabilizers, yes. Rail connector. Let's gate all this by bringing this down to 1. Looping it back. Sending it to the left. A rail connector to bring these back one more time. Nope. There we go. And then we need a rail support in the front. And a rail connector here and here. Bring these back forward. I missed. There we go. Multi-rail supports. 1, 2, 3, 4 now. This is going to be 16 through 20. So it's going to go all the way to the end. This is going to be 16. This is going to be helium-3. And this is 14 and 15. There we go. Bring everything else forward. Okay, there we go. I did have to push these 2 out, 1, because they wouldn't go back up without intersecting other rails. So now we're up to 16. Next up, we're going to have a single fabricator V2 of stators. Put this right here. Stators are housings, wire, and sheets. I'm gonna have to refresh my memory on where we put these things. Okay. For that, we're going to need 6, 8, and 9. So let's grab... let's go down 1, 2. We need to set our Z. 6 will go to the left 1. Should be just like this. 6, 8, and 9 should all be off of this support, this pole. So 6, 7, 9 is here. 8, like so. We'll gate these backwards. 1, 2, 3. Swing it around. Go to the left. And up. Make me some stators. Here it comes. Very nice. Wire. Housings. Plates. Beautiful. Okay. Let's hit our output back on. All the way down. All the way down. Might as well connect this now. So we just have to worry about working over here. We're gonna bring our multi-rails forward. 1, 2, 3, 4. Make sure we can get everything forward again. And 10 is gonna be an issue. And I don't really know what we can do about that. What if we send 10 through first? Rail connector. I know sometimes you're allowed to clip if you go... There we go. We'll take advantage of some positional clipping bugs. And then bring this back up. We'll do this in reverse, I guess. Like that. That'll work. Alright, bring everything else forward. There's 16, so now we're on 17. Let's bring a connector all the way through. Hello. Thank you. All the way through to... Please, here. Good grief. Then up to 17. Okay, there's another one down. Next up, a mega press, well, 4 mega presses worth of valves. Mega press. Oh. Bring this down. Lock our Z. 1, 2, 3, 4. I think it's just uncomfortably close to White Lake. Rail connector. Bring it all the way down. Keep sending it back. Let's see, can we go from here... there? Yes, we can. Okay. We'll rail all this together. Now, let's take a look at our recipe. Valves, titanium housings, beams, rods, and nozzles. Valves. 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 And for this, we're gonna need 7, 8, 12, and 16. Let's bring this down. 1, 2. Lock our Z. Let's do 7 and 8. 7, 8. 5, 6, 7, 8. Then 12 and 16. 12 and 16 should be our nozzles, yeah. Run these to a secondary bus in the back. Yep. Loop it back. And then send it to the left. Nope. And connect it to the machines. Let's see. There's housings. There's beams. There's rods. And there's nozzles. Perfect. Okay. Rail connector, this is going to be... this is 16, 17, this will be 18. We also need to collect all of our outputs. Send this across. Nope. The rail targeting is being extra finicky. Up to 18. See if we can get everything forward again. 17, and then this is 18. Okay, perfect. All right, we're getting down to the end. Impellers times 4. Mega press. 1, 2, 3, 4. Rail connectors. All the way down. 2, 3, 4. Then rail support. Bring it down. Like so. So, for impellers, we're going to need titanium rods, heat-resistant sheets, wolfram plates, and stabilizers. Is that our recipes? Impellers. 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 Okay, so rail connectors. Let's bring this down. 1, 2. Lock our Z. We're going to need wolfram plates from 11. Rods from 12. Heat-resistant sheets from 14. And stabilizers from 15. This is going to... well, this is actually not going to be too bad because all of these are end of the line. So none of these will need to get back onto the line. I just need to make sure we can get everything off the line first. So let's actually extend this forward first. I'll put this 1, 2, 3, 4. And we have to, if we know we're going to have some weird bends on things, we have to put down our straight throughs first. So starting at 11, 12, 13 is not going, so let's put 13 through. Then we have 14 and 15, so we'll do 11, 12, 13, I guess let's do 15 first. There we go, and then none of these need to come back up again, so we should be good to get all these forward, right? Yeah, okay. So let's get our secondary bus in the back. 1, 2, 3, 4. We'll loop these around. Send these to the left. Like so. Here they come. Traffic's picking up. All right. While that's loading up, let's send all of our... This is getting so old. Something about these multi-rail 5s, they just don't like to connect. There's like 5 targets here that it could have glomped onto, but instead it decided it wanted its own rail support. I don't get it. Okay. Let's get this back up onto our 4th pole. Bring this through. This is going to be 19. There we go. I see everybody's slurping up product. Let's take a look. We're gonna have a bit of a glut here until these buffers fill. Yeah, we'll let that work itself out. For now, I'm running out of building materials. How do these get all moved around? There we go. We'll drop these. Next up, we're gonna have yet another cargo receiver. This one's gonna be pulling down sulfuric acid. From our last available SACD TX9, SACD RX9. Let's bring our rails forward again. And I think I'll put this on 1, because 1 and 2 are available now because we discontinued titanium and wolfram bars. So I'll send all these through. Actually, let's do this on 1, right? So we'll do rail connector to 1, and then we'll bring all these through. And 19. Perfect. Okay. Now we need 3 mega presses of turbines. Lock our Z, flip it around. 1, 2, and 3. Rail connector. All the way down. And finally into a rail support. All the way down. Okay, for this we're gonna need... Where are we? Here we are. We're making turbines. We're gonna need impellers, stators, rotors, and sulfuric acid. Turbine. Turbine. Okay, rail connectors. We're going to need sulfuric acid on 1. Lock our Z. So there's 1. We're going to need rotors on 13. And then stators and impellers on 17 and 19. So sulfuric acid. Rotors on 13. And then 15, 16, 17... No. 16, 17, 18, 19. There we go. We'll bring these down. Secondary bus in the back. Loop it. Send it to the left. Here comes some. Here's our sulfuric acid. There's our impellers. There's our stators. There's our rotors. All right. While that's filling up, let's bring our multi-rails forward one last time, I think. 1, 2, 3, 4... Is that right? Yeah, that's right. We can bring these all the way to 20. Perfect. We'll bring sulfuric acid back up. Our impellers need to go back up. Those are 19. And then everything else can be dead-ended. So we'll just bring the rest of our rails through for aesthetics. There we go. Okay, and at last we have 4 mega presses making pumps. So, mega press, lock our Z, 1, 2, 3, and 4. Rail connector, all the way down. Okay, brought everything forward. So let's set our recipes. These are going to be for pumps times 4, 2, 3, and 4. And we're gonna need to bring in valves, turbines, impellers, and sulfuric acid. Okay, rail connectors. So we're gonna need sulfuric acid on 1. We're gonna need valves on 18, impellers on 19, and turbines on 20. So let's just do 1, 2, and 3. We don't need to bring anything else forward. Sulfuric acid. And then this is 16, 17, we need 18, 19, and 20. 18, 19, and 20. We'll bring this all backwards. Oh, I did not do that at the right height. Crap. And you know what? We don't have to. This doesn't need to be gated because this is the last stop. So this doesn't matter if they get joined together. So we'll do that. Just because I'm running low on time before the rupture hits. And this happened. Nope. Nope. No. This one. Good God. The targeting is so bad. This one. There we go. And then you, please. Into there. And that should be it. Alright, let's house up. Hab up. Airlock. And I'll see you after the rupture. Okay, I think we'll convert this into a rail connector so that we can send this immediately to the right into a storage depot V2. Like so. We'll collect pumps. There they come. And then finally, we're gonna feed these into a dispatcher. So this is 24 pumps per minute. This is a paltry amount of pumps, so this is only gonna require a single cargo dispatcher, which we'll put here. One out. One in. Collect pumps. We'll call this extra pumps. Now we'll just set a receiver up in our mega press factory and then feed that into our existing stockpile of pumps to supplement that. So let's take a look at this factory that we made real quick before we take off. We made 2 full factories this episode. Let's do no UI. There we go. We have our input line coming into our first node, or our first pole of our main bus. We've got all of our low-level manufacturing, plates and rods and wires, big loop-de-loop, and then all of our mid-tier manufacturing, mega presses. And finally, all that into a dispatcher. So, there we go. So, back at the Mega Press factory, I've kind of built this into a corner. We don't really have room for anything, so I think what I'll try to do is move this pillar back. When we go back 2 places, bring this up 1, 2, and then get rid of this pillar.
Arcadia 7 has finished regenerating.
And that should give us enough room to put in a cargo receiver down here at the bottom. Perfect. And then how do we want to get this in? I guess we can connect it to that lead right there. So if we take this out to here, and we want to get this right into there, and then that'll circle around back into this, which will then go into this, and that way our pumps are available to everybody that needs them. So we'll set this to pull down extra pumps. Extra pumps, pump it. Okay. And there we go. So now what I'll need to do is delete these extra mega presses that I installed earlier that are overtaxing our existing supply of parts for mega presses. So we had 4 in the other factory, 5 and 6 total, which actually brings us to 1 over what we need. We need 5 total pump manufacturers or pump mega presses for satellite body production, so we have more than we need now, all fully supplied and not straining any of our existing manufacturing lines. So now that that's cleaned up, we can get back to waiting for our rocket engines. Okay, it's finally done. Let's go to Facturer. Satellite bodies. Let's turn in 600 rocket engines, 800 onboard instruments, 100 scanners, 400 ion thrusters, and 8,000 data points. Finally! Now we can get to the real weight. So we'll delete the habitat. Let's hop up top. Facturer. We're going to be manufacturing satellite bodies. There's our scanners, onboard instruments, ion thrusters, the few rocket engines that have been made since I was turning in the materials, and heat shields slowly pouring in. So this is a 20-second manufacturing time. Again, we're going to need 1,070 of these. However, we're not going to run this just yet because we still have a few ranks of Clever Robotics to run up before we even need to turn these in. So I'm actually going to turn this off for right now. Let's go take a look. I guess I probably should not have destroyed that hab because we're still going to need one to look at the corporate terminal. Well, not necessarily. I can just throw down an OCL and we can look in the OCL what Clever Robotics wants. So Clever Robotics wants superconductors that we don't have, heat shields, which we do have, and rocket fuel, which we do have. Rocket fuel is probably going to be the easiest one to turn in, although we can probably do heat shields and rocket fuel. But if we come over here, we have oodles and oodles and oodles of rocket fuel, and we're already filling up a second storage depot worth, so we'll hook up an OCL V2 to this storage depot, and we'll use this to turn in rocket fuel. This is actually going pretty quick. At a full stack, giving us 25k per stack, we have like 1.25 storage depot V2s full of these things. So each one of these, 1, 2, 3, 4, so 25, 50, 75, 100. So 100k, 200k, 300k, 400k, and then maybe whatever's left in here, or was left in here, will get us to 500k. So we should be able to get through this relatively quickly on just rocket fuel alone.
Cargo received.
There we go.
Clever Robotics thanks you for a particularly speedy shipment.
That was actually pretty speedy.
Await you in the terminal. They are extremely impressed that, despite your fragile protein structure, you're able to be so effective.
I'm sorry, are they actual robots at Clever Robotics? All right, let's dump this back in here. We've absolutely devastated our rocket fuel supply, but that's okay. Let's move on to, I guess let's pop down another OCLV2 and see what Clever Robotics wants next. They want rocket engines and ion thrusters. So those are produced right next to each other, right? This is ion thrusters here and rocket engines here, relatively close. So how do we get these together? I'm gonna have to turn this, actually, this is perfect because these both come into this rail connector right here. Kind of. What I'll have to do is do a rail connector again down here. Somewhere where I can fit 2 OCLV2s in. OCLV2. 1 and 2. I'll do, I guess a rail modulator will work. Like this. 1 here. 1 here. Every time I'm doing something critical, it autosaves. It's never when I'm like running in between factories or waiting for something to turn in. There we go. So now we have access to both of those. Let me over. We'll set 1 to rocket engines. There we go. Stealing our few precious rocket engines that we had built up, and then 1 for ion thrusters. There they go. We're at a mere 40. For 32. And 57. So this one's going to take a bit. So let's meet back up when we're ready to turn this in. And we'll wrap up with getting started on our satellite body turn-ins, but we're just about across the finish line.
Great work.
And there we go.
Has received your shipment. As usual, your reward waits for you in the terminal.
Just at the end of golden hour. That was about 2 hours. In fact, I almost missed coming back to it. I had to run to the bathroom. Let's then, I guess we don't even really have to move these, we just need to delete 1. And we'll take the output of this, no, the output of this, right? This is gonna be our rocket, or our, satellite bodies. So we'll disconnect from this, and we'll connect it to this instead. We can leave that on there, why not? So let's get back up here. Turn this back on. Oh, I even got a bonus ion thruster for my trouble. Power on. There we go. We'll set this up to deliver satellite bodies to Clever Robotics. Boom. Interestingly, this is only, I guess this is, because it's only level 13, so level 15, this is only 847k. So it's going to be slightly less painful. Slightly less than 6 hours, but let's take a look in a hab. We'll toss down an airlock. Show me a corporate terminal. Corporate terminal. We can claim, oh, multi-storage we got at level 12. I didn't even realize. Stores excess items that can't be sent anywhere else. Holds up to 2,500 units. Can store different items together, so we'll claim that. We'll claim our quartz ore, and then we have just one level left, level 14. Perfect. So I guess let's check out, before we outro, let's check out the multi-storage. I've never actually used these before. What are they in? Multi-storage. Plop it down. Very neat. It's got one... Isn't there a V2 of this? There's some kind of storage unit that has 2 rails in and out. We can put whatever we want in here. And this will pull in anything, like if you put this at the end of like a sushi belt or something, this will pull in anything that doesn't have a home. This will act as the home for it, so it will pull in, like if we put this on the end of our bus that we just made and like used a bunch of 5-to-1 rail connectors to bring all of our 20 individual rails down to 1 and bring this into here, this would just suck in everything out of our bus because it will take whatever's not being used anywhere else, if I understand that correctly. Let's take a look at a development terminal or development station, because I think there's another version of that. Development. Clever Robotics. Yeah, the expandable storage. So this, you can barely see in the picture, actually has 2 rail inputs, which is kind of crazy. That means it has 8 different connectors. Can store up to 1,600 units of one item, can be expanded using more power. So you use power to expand it. Very interesting. What do we need for that? Total power available ingredient. A little bit more power, and then 90 quartz ore and 30 ignitium. And we'll take a look at that in the next episode, but that 2-hour wait kind of sucked the enthusiasm out of me, so we'll destroy this. We'll take one last look at the factory that we built here for Clever Robotics. F1. Hide our UI. Take a big peek. Again, not a humongous base, definitely smaller than the one that we just made for pumps, mainly because we only needed to make 6 items here, but a little bit better put together than the one that we made in the last episode, at least as far as aesthetics. I'll circle back afterwards when it's screenshot time for the thumbnail and put in our expandable walkways for that last row there, but otherwise this has been mostly put together into one cohesive factory, so there we go. I like it. We'll screenshot that. That'll probably not be the screenshot that I use for thumbnail, but always nice to have multiple angles. And there we go. So just like last time, we're going to let this run in the background over the next couple of days. I'll have this up on the side, and we'll wait for whatever slightly less than 6-hour time interval it's going to take to turn in 847K worth of satellite bodies, but it's more than I want to wait for in this episode. So that's going to be it for this one. If you're still with us, thank you for watching. If you're enjoying this playthrough of StarRupture, hit like and subscribe. If you want to check out StarRupture for yourself, head over to Steam and pick it up. And if you want to let me know what you think of the game so far, then hit the comments down below. But whatever you do, I'll see you right here again in the next one. So, until then, bye-bye.